Next content is oxidation number. Oxidation number helps to determine the oxidation and reduction reaction takes place. Oxidation number. What is oxidation number? Oxidation number gives idea that how many electrons are lost. How many electrons are lost or gained by an element. Okay, in order to form a chemical bond or in order to combine with other element. When an element combine with other element and form a compound, that time the element either loses or gains the number of electron is called oxidation number. So what is it? Is the number of electron loss or gain by the element in order to form a chemical bond with another atom. Okay, and this oxidation number given either positive sign or negative sign. Right? Oxidation number have positive sign or negative sign. Okay, it is given, or positive sign is given. It is given when electron is lost, and negative sign is given when electron is gained. Okay, and generally this oxidation number is sometimes real or sometimes imaginary. Okay, oxidation number value are real in case of ionic compound, okay, and imaginary in case of covalent compound. Because in ionic compound electron is lost by the cation and electron is gained by the anion, it is real. But in case of covalent bond, that is mutual sharing of electron occurs. No electron loss or gain takes place. Okay. Let us consider an example, KMnO4. Here the formation of KMnO4, Mn either loses or gains some number of electron. That is called oxidation number. So what is the oxidation number of Mn? We don't know the oxidation number of manganese. So we have to calculate. Let us consider the value of manganese, or oxidation number of manganese is X, plus oxidation number of potassium. Oxidation number of potassium is +1, and oxidation number of oxygen is generally -2. Okay, and this compound KMnO4 is neutral. So sum of oxidation number of all the elements equal to 0. Okay, so X minus 7 equal to 0. That means X equal to +7. Here the oxidation number of manganese is +7. Okay, for the formation of KMnO4, manganese loses 7 electron. So the oxidation number of manganese is +7. Okay. There is a doubt. How can you know the oxidation number of पोटासियम इज +1, ऑक्सीजन इज -2? वो कैसे आपको कैसे पता चलेगा? उसके लिए आपको एक रूल पढ़ना पड़ेगा. ठीक है, ये रूल के बाद, ये रूल में जो भी मैं वैल्यू -2 +1 यूज कर रहा हूँ ना, वो वहीं पे आ जाएगा. ओके, सो रूल फॉर डिटर्मिनेशन ऑफ oxidation number. What are the rule? First rule is rule number 1. One is, if any element is in its elemental form, what is oxidation number of an element in elemental form is 0. Elemental form is 0. Oxidation number of an element in elemental form is 0. Okay, elemental form means if an element is present like this Cl2, that means an atom combines with same atom, Cl combines with same. So your oxidation number of Cl is 0, and oxidation number of another example is O2. Oxidation number of oxygen is 0 because oxygen combines with itself. Oxidation number of P4 in phosphorus is 0. Phosphorus combined with self. Oxidation number of sulfur in S8 is 0. Oxidation number of Fe. Fe is iron. Iron is present in free state. There is no positive or negative charge. No charge. So oxidation number of Fe is 0. Okay. What is elemental state? Elemental form or elemental state? This is simple. If an element is present singly, not carrying any charge, or combine with itself and not carrying any charge, are elemental form. Okay. Then second, third, fourth again rules are for combined state. For combined state. Combined state means that atom combines with other atom. Combines with other atom. Point number 2. Oxidation number of alkali metal. Alkali metal. Alkali metal, that is group 1 elements. Alkali metal or group 1 elements. Okay. Lithium, sodium, potassium, rubidium, cesium is always +1. Okay. Then oxidation number of alkaline earth metal. Alkaline earth metal is group 2 elements. Group 2 elements are beryllium, magnesium, calcium, strontium, barium is always +2. Okay, that means if lithium, sodium or potassium, rubidium, cesium is combined with any atom, then its oxidation number is always +1, and oxidation number of these elements are always +2. Then oxidation number of F is always -1. F is always -1. Okay, always -1. Then rule number 5. Oxidation number of hydrogen. Fluorine combines with any element, its oxidation number is -1. This is always. And oxidation number of hydrogen. Hydrogen have two oxidation number, that is +1 and -1. +1 is used when linked or attached with non-metal. When hydrogen is linked with non-metal, then its oxidation number is +1, and -1 when attached with metal. Okay. 6. Oxidation number of oxygen. Oxidation number of oxygen is generally -2. Okay. This is not always, this is only in general state, means in general state this is -2. There are some states where oxidation number of oxygen is -1, -half and +1, +2. In oxide is your O2 minus. Here oxidation number is -2. Oxygen generally present in this state. And in peroxide is O2 2 minus, its oxidation number is -1. In superoxide is O2 minus. So there is one negative charge on 2 oxygen atom. That means its oxidation number is -half. Okay. In O2F2 or OF2, in O2F2 oxidation number of oxygen is +1, and in OF2 it is +2. Okay. Then last rule for sum of oxidation number of all the atoms in a molecule or ion is equal to net charge on that molecule or ion. Consider this example, that is KMnO4. In KMnO4 oxidation number of manganese. For potassium your oxidation number is +1, for manganese you don't know, so X, and 4 into -2 for oxygen equal to 0. So oxidation number of manganese is +7. Okay. And the last rule for calculation of oxidation number is, in known cases oxidation number is equal to valency. What is the known case? Consider this example. Example is, suppose in case of FeSO4, you have to find the oxidation number of Fe. FeSO4 is your known case. You know SO4 is present as SO4 2 minus, which is sulfate. So if there is SO4 2 minus is present, then Fe is present as Fe2 plus. So oxidation number of Fe is +2. Okay. Yes, these are the simple rule, and there is a question: calculate oxidation number of the following underlined element. You have to complete this example, and then we will discuss in your class. K2Cr2O7 oxidation number of chromium. H2SO4 oxidation number of sulfur. HNO3 oxidation number of nitrogen. H3PO4 oxidation number of phosphorus. Okay. In H2O2 oxidation number of oxygen. In HNO2 oxidation number of nitrogen. Cr2SO4 whole 3 oxidation number of chromium. In SO4 2 minus oxidation number of sulfur. In NO3 minus oxidation number of nitrogen. In NH4 plus oxidation number of nitrogen. Okay, and last one is in CO3 2 minus carbonate oxidation number of carbon. Complete this, then we discuss in our online class.